Kinetics and kinematics, two branches in physics that deal with the motion of an object. Although both terms sound similar, there are still differences between them. Kinematics describes the motion of a body using equations of motion, while kinetics explains how a body reacts to when a force or a torque is applied to it. And these two branches in dynamics can be seen everywhere, from driving a car to throwing a ball. And today, we're going to be looking at a common concept in kinematics called absolute dependent motion.
Absolute dependent motion can be seen in a system with inextensible cords and pulleys where motion of an object depends merely on another. Each particle in the system is moving in rectilinear path, which is moving in a straight line. To analyze an absolute dependent motion, some steps must be taken to calculate the velocity and acceleration of the object. The first step is to set a datum. A datum is defined as the reference or fixed starting point which is set at the pulley. The next step is to define the position coordinate. The position of the object is measured from the pulley, which is the datum line, and the downward motion is assumed as in positive direction. The equation for the total length of the cord is then derived. To find the velocity of the object, the equation for the total length of the cord is differentiated with respect to time. Since the total length of the cord is constant, the differentiation will give 0. By substituting the given velocity of an object, the velocity of another can be found.
Hi, my name is Abdoulfatah, and today I'll be presenting on how to calculate velocity in a pulley system. This is system 1. There's a single pulley and a single cable. First, we need to find the datum point, and the datum point is going to be from the fixed point, which is from the pulley here. We draw the datum point, and to find the position coordinate of A, it's going to be from here to here, which is going to be SA, and position coordinate of B is going to be from the datum to B, which is going to be SE, equals to the total length of the cable. Then we differentiate the equation to get VA plus VB equals to 0, and we rearrange the equation to get VB is equals minus VA, and it's minus VA since B is going upwards and A is going downwards. For system 2, there's 3 pulleys and 2 ropes. So first we need to find the datum point. The datum point is going to be the fixed point in the pulley, which is going to be the first pulley since it's not moving. Then we need to find the first equation, which is for the first rope, which is going to be the position vector of A is going to be from datum to here. So SA plus the position vector of B, which is SB, plus the position vector of B, which is going to be SB again. So SA plus 2SB equals to the total length of the cable. And the second equation is going to be for the second cable, which is going to be SC plus SC minus SB to find the distance from this to here equals to length 2. Then we sub the first equation to the second equation to remove SB. Then we get 4SC plus SA equals to L2 plus L1. Then we differentiate this equation to get the velocity, which is going to be 4VC plus VA equals to 0. And it's equal to 0 since when you differentiate the constants, which is 2L2 plus L1, you get 0. Then we rearrange the equation to get VC equals to minus 0.25 VA. And it's negative since it's going upwards. And this is system 3. There's one cable and there's a single pulley. So first we draw the datum point, which is going to be here for this one, and find the position coordinate of A is going to be from here to here, which is SA, plus the position coordinate of B is going to be from here from the datum to B, which is SB, equals to the total length of the cable. Then we differentiate the equation to get VA plus VB equals to 0. Then we rearrange the equation to get VB equals to minus VA, and it's negative since it's going towards the datum point. And we can notice that it has the same calculations as the first system, since we assume that there's no friction in this system, like there's no friction.
In conclusion, the pulley system mechanism experiment has demonstrated the kinetic and kinematics working principle. The kinetic in this pulley system deals with causes of motion, that is force, gravitational force, tension, as well as frictional force. On the other hand, the kinematic deals with the position of the moving objects in terms of its acceleration and velocity. Based on the absolute dependent motion, we know that when particles are interconnected by a cable, the motion of the particles are always dependent. Besides that, pulley can also provide us with mechanical advantages when we use several together and more rope. This process lessens the amount of force required to lift something. After understanding the principle of kinetic and kinematic in this pulley system, we are able to calculate the mathematical problem with much ease. That is all we have in this video. Thank you so much for watching.